Brace yourselves, dragons are coming. While some men want to watch the world burn, our hero Johnny Snow is using a flame-throwing grand immolator to learn how he can design a shield to survive a dragonfire attack and win the day. Devising a defense against a flame attack is dangerous and expensive work. Johnny cannot take any chances, so he turns to the magic found in SOLIDWORKS flow simulation for answers. Virtually testing your dragonfire shield is especially helpful when you want to avoid roasting fresh recruits or mortgaging the throne for new prototypes. Johnny finds the setup of his analysis in SOLIDWORKS flow simulation simple and straightforward. Johnny sets up the problem as an external flow analysis, excluding all internal cavities to speed up the solution. As he is dealing with dragonfire, heat is important in this analysis, and so he includes heat conduction in solids. From historical eyewitness accounts, he has estimated that a dragon's flame attack lasts for roughly 3 seconds. This determines his choice for the total analysis time. He knows that the dragon flame gas is very dense compared to air, so gravity must be included. Johnny now needs to add the gases he would like to use in the analysis. The main fluid in the model is air, and so this is selected from the predefined list. He also includes a dragon flame fluid he created earlier and saved in the user-defined material database. Next, he selects a default solid material for all solid bodies in the analysis. For this, he chooses insulator as a dummy material. Any bodies with properties which are significant to the analysis can be changed later on. The initial ambient conditions are set next, defining the starting temperature for the air and solid bodies. The last step in setting the basic mesh settings, Johnny turns on the advanced narrow channel refinement and optimized thin wall resolution features to create a high-quality mesh around the flame nozzle and the foot soldier and his shield. Johnny now adds the flame attack. He uses a fan and the dragon flame material he also created previously to mimic the flame leaving the dragon's mouth. With the problem set up, Johnny sets the analysis running. At first glance, it's not looking good. At the end of analysis, our foot soldier is surrounded by an air-flame mixture at 125 degrees. Not something he could survive. Johnny has set the temperature scale so that anything over 75 degrees Celsius is shown in red. If the foot soldier experiences temperatures of this level for any length of time, he is in severe trouble. He animates the results to see what happens and what he might do to solve any problems. Very quickly, the hot flame at 75 degrees Celsius plus curls over the top edge of the shield. The soldier would be blinded and in extreme pain instantly. The shield protects the soldier initially from the flame and creeps along the floor and flows up under the shield before the flame flows in from the back and finishes the job. Johnny can see that the shape of the shield causes the flame to curl around the edges. Good thing this is a simulation and not a real member of the City Watch. From a quick simulation, Johnny knows he needs to redesign the edges of the shield, and the foot soldier needs to change his stance, ensuring the shield touches the ground. Johnny redesigns his shield with curving edges to hopefully redirect the flame attack. He updates the shield in the SOLIDWORKS assembly. It looks much larger. Mass might be something he'll need to look at later. He changes the stance of the foot soldier so it is protected behind the shield with the bottom edge on the floor. Finally, he creates the new configuration with the upright mannequin replaced with the crouched mannequin in the analysis assembly. With his new configuration created, Johnny uses the clone option to copy his original study, but use the new geometry configuration, and he is ready to rerun his problem. The analysis is ready to run, and soon he'll discover whether the new shield design will deflect the hot flame away. Johnny looks at an animation of the temperature profile. The animation shows that for a very brief period, the temperature reaches 65 degrees. Otherwise, it's well within comfortable limits. Looking at the results from above, Johnny can see that the new shape of the shield prevents the flow from curling around the back of the foot soldier. In fact, the flow appears to spread further apart as time progresses. Johnny now has a shield design which works against his own grand immolator. But how would it fare against the real thing? Johnny has made one further design improvement for use against the dragon. He's added a helmet to prevent being burnt by any flame curling over the top of the shield. He's also added an emergency cooling system which blows cold water over the surface of the shield at high pressure. Johnny survives the attack of the real dragon. Now Johnny knows everything about CFD, and the realm is saved. The SOLIDWORKS Simulation Suite provides advanced tools to solve your most challenging design problems. SOLIDWORKS Simulation makes it easy to see and understand how your products will perform under real-world conditions without having to build expensive and time-consuming prototypes. SOLIDWORKS Simulation gives you vital information that can help you make good engineering and design decisions, making your products better and your customers more satisfied. To find out more about SOLIDWORKS Flow Simulation and other simulation tools, contact your local SOLIDWORKS reseller or visit solidworks.com/simulation. Don't take on the competition unprepared. Know that your products can beat the heat with SOLIDWORKS Flow Simulation.